How was lunch? Yeah, amazing. So a friend in the front row said earlier, you're all here not because I'm necessarily interesting, because these are the comfy chairs. So after lunch, we're going to get back to lunch in a second. But before we do, I want to tell you a story. So it's last Wednesday, 4 p.m., dinner date right after work, and you're trying to, finish things up and get things going so that you can get on your way. So git commit, right? Pre-commit runs, everything looks good. Tests are passing, so we git push, right? Everything's going on to GitHub. GitHub Actions spins up, you start seeing green. Does this sound familiar to people? Day to day? No? Really? No DevOps people here, right? No one ever pushes that. There we go. Liars. And then you know what the rest of the story is then, right? Because if you raise the hand and you're really DevOps people, you know how this story goes. Because things are going fine. You go home, quick shower. You're on the way to the restaurant. And what happens? Beep, 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 beep. Pager duty. We love pager duty because they do things like give us lunch. But we hate what they represent, which is, misery after hours after work. So what the hell happened, right? So, oops, wrong way. My name is Issac Goldstand. I've been developing applications for 20 years professionally and more as an adolescent, just on my own. Hopefully in the next 15 or so minutes, hopefully we'll answer that. But before we do, because we're after lunch, I don't know about you guys, but lunch was nice and filling and my head is like a little bit groggy. So I want to do a short breathing exercise, and I invite you to do this along with me so that we get oxygen to our brains and we move from that comfortable, I see it in your eyes, oh, lunch, and asado, right? So I'd like to invite everyone to close their eyes just for a few seconds. Focus, take a deep breath in, breathe all the way in. Hold the breath and breathe out all the way. We're going to do it twice more. Breathe in. We're oxygenating the blood and bring oxygen to the brain cells. Breathe out. One last time. Breathe in. And breathe out. And you can open your eyes. All right. How do you all feel now? A little bit better? A little bit better. Yeah. Yeah. All right, so I was saying I've been developing applications for over 20 years. I remember token ring networks, right, back in the 80s. I remember the internet coming out in the early 90s. I remember websites turning into web applications in the 2000s. And then in 2006, Amazon came along and changed all the rules of how we knew infrastructure and web deployments with AWS. Things have changed a lot. For example, a few years ago, right, people were working in kind of web development, right? You'd have your development environment on your laptop, right? You'd have maybe a shared playground where everyone can test their code together. You'd have a single QA. Everyone remember waiting in line for the QA environment, right? And then things would go to one-to-one staging environment. Things would get tested and finally pushed into production. And if you did client development, right, then it was a similar story, right? You developed on your laptop, you built on your laptop. Maybe if it was a production build, you'd use like the company Jenkins server or whatever. But that was it. Now, if we fast forward to today, things are very different, right? We have these throwaway environments all over the place. My God, is that Shona Zenachon? אני כבר במחצית זמן? No, okay. Phew. So we define our pipelines in code, right? In Jenkins and in GitHub Actions and in Azure Actions. We define our environments as code. We define our infrastructure as code. Everything's code. And what happens is when we push, a commit, all this automation comes in, some orchestrator comes in, starts reading these files, building up our infrastructure, installing all of our dependencies, running our workload, right? And the workload could be a compile, it could be a Webpack, it could be a test, it could be DevSecOps, some sort of security scan, or it could be our production workload, right? And then when we're done, Great. So we take the infrastructure, we pull everything down, we throw it in the trash or the recycling bin, right? And we're all done. So ephemeral environments are great, right? They're so great that we want to use them more. And, why not? They're very cheap. They're very easy. They're very clean. So I don't know about you guys, but my name is Isaac, and I am addicted to these ephemeral environments. Thank you. So what's the problem with this? The problem is chaos theory, right? The evil butterfly. Chaos theory says that, a small amount of complexity in one place is going to potentially create a disaster somewhere else, right? And how does that relate to us? It relates to us because as engineers, to combat chaos theory, we want to use the KISS principle, right? Keep it simple, stupid, or whatever you want to put instead of that. I hope I didn't offend anyone with the S word. And we use that by reducing variance. We reduce variance in the artifacts that we deploy by deploying a single artifact to many environments often. We reduce variance by prepackaging dependencies, right? People who saw the opening remarks with cybersecurity, remember all those dependencies that became more dependencies. That was scary. And for people who worked with Node.js maybe back in 2016 and remember the left pad incident, right? Anyone? No? Yeah, see? Everyone else, go Google left. Don't do it now, right? I still have more cool things to say. But after this, Google left pad and understand what problematic upstream dependencies could do with you and how much clutter and crisis they could do. So we have cookie cutter artifacts running on cookie cutter environments, but we still need some variance in the runtime configuration, right? Even if it's just to change the application log level, right? Or the verbosity of the logs that we're sending, right? And hopefully also your database credentials aren't the same on localhost as they are in production, right? And don't get me started on multi-region auto-scaling clusters where names change and things come and go all the time. So we need to manage the runtime configuration. And despite all the evolution I've spoken about, configuration management hasn't changed that much during the time period. And I'd like to go look at 3 patterns, right? And when we look at these 3 patterns, I want us to understand how do we get these to work for us and not surprise us during our dinner date. And we're going to see how we can mix and match them. So we're going to start with embedded configuration. Embedded configuration, as we say in Hebrew, pshuto kemashmouto, right? And for the non-Hebrew speakers, it basically means it sounds exactly like what it is. Okay, we embed the configuration inside of the artifact. We typically inject it at build time. The data source is stored alongside either as part of the source code or as part of your CI or continuous integration variables, right? And if there's anyone here who remembers C, C++, right, with -d debug or -d release, that's basically the idea. We're doing something that's going to inject the source code, the configuration into our runtime. And we do this in places where we can't control the runtime environment, or what I like to call the execution environment, the environment where our code is ultimately going to be executing, right? And examples of execution environments for embedded configuration can include an Android application, right, where you don't really know what kind of phone it's going to run on. It could be a Java SDK or software development kit, right? A library that some other developer is going to embed, and you have no idea where the hell that's going to end up. It could be IoT or Internet of Things firmware, right? You're embedding something to go on a device. Now, maybe the device is running in a network here, which is secured, we hope. Or maybe it's running on someone's, public Wi-Fi in an internet cafe, and we have no idea. So the idea is that as a developer, we don't know where it's going to run. We can't guarantee that we can trust our environment to get the configuration, and therefore we have to embed it. And for those cloud developers or cloud DevOps people in the audience thinking, well, thank God that's not my problem, I say, hold that thought, because I bet it is, and we'll get back to you soon. The next pattern I want to look at is what I like to call runtime configuration. Okay, at runtime configuration, we pass our dependencies to the process, and the process reads them at startup. Okay, this is the ops equivalent of the dev pattern of dependency injection for people who've worked with that, right? Where you send all of your actual configuration to a class that you're instantiating. The origin data could come from a number of data sources. It could come from your infrastructure and code and be sent to the infrastructure to be read by the process. It could be stored alongside the Git, although not everything necessarily goes there. Maybe you have like a config file with sane defaults, right? And the kind of things you're typically going to want to be doing with runtime configuration are dynamic things. So things like host names, credentials, log levels, like we talked about before. Sometimes we'll want to have values, secret values that we might store in an external store like AWS Secret Manager or HashiCorp Vault. And we'll come back to that if I have time in the next pattern. But the idea is that because the variables, no matter how sensitive an individual variable might or might not be, these variables control how our program is going to work. And therefore, by definition, that whole thing is sensitive enough that we only want to do this in a trusted environment where the developer has full control of the execution environment. And this is a really important concept in modern build and deployment pipelines, or CI/CD for all of the buzzwords fans out in the audience, right? Where we have a desire to create a single artifact that's going to run across dev, QA, staging, production, right? All of our execution environments. Now, the way that we pass the data, like there are a lot of ways to do it. It could be runtime arguments. It could be environment variables. It could be files. It could be a combination. The mechanism is really up to you, but there are patterns. Like, for example, with containers or serverless applications, people tend to like injecting environment variables. Does that make it right or necessarily better? No. It's just easy and convenient. And when you're using runtime configuration, that's what you need to be looking at. What's the easiest and most convenient way for you as either the developer, the DevOps, the platform engineer to make sure that the variables get to production. The last pattern I want to look at is something called dynamic configuration. And this is more powerful, in my humble opinion, and less popular than the others that we've looked at. And in this pattern, the configuration is stored somewhere externally, and we fetch the values at runtime. Okay? Now, fetching at runtime is different than what we just talked about with runtime configuration, because in runtime configuration, we read those variables once at process start, and if we want to change something, we'll normally have to either restart the process or, if we're running in a cluster, send a rolling update, whatnot, and that can have consequences. Right? The consequences can be the network connections have to be restored. It could be I have an in-process cache for some popular variables, and I'm going to now have a cold cache. It could be the few milliseconds that it takes when it goes down and then it comes up. Right? That's if you're a very busy application, you're going to see spikes on your load balancer from that. Now, in contrast with that, with dynamic configuration, we can read and reload these variables without a restart. For example, we could send a SIG-user1 signal to the process, and it will pull the variables or reread the variables from wherever it read them the first time. Now, this is also different than runtime and embedded configuration because of security concerns. So, we said that all parameters, or all configuration values are somewhat sensitive, right? Because they affect how you run. But some are really super sensitive, like your database password for production, where you keep all of your customers, credit cards or passwords, or right? Well, we don't want those to leak. And when we use runtime configuration, we have a little bit of a problem, because even if we're sending it directly to the process, right, through an environment variable, right, another process on the same machine, right? And don't talk to me about it's serverless. There's no such thing as serverless. There are other things running on the machine in 90+% of the use cases, right? So another process can see variables in the environment. They could see, the process list and see what runtime arguments you sent the process. They could read a file with those same permissions. Someone with read access to your CI system, to your continuous integration system, right? They might have access to see the variables that were injected into the environment. Right, so you're going to have secret leakage. Now, with dynamic configuration, we're actually querying from inside of the app. So there's no set of sensitive variables remaining anywhere where they shouldn't be. So they don't exist, somewhere on the operating system level to be read. They don't exist in some sort of CI where someone with read-only access system to your deployment could see these. And that enables us to have a tighter security perimeter and enables zero trust, which is a very, very popular trend in the last few years. I mentioned earlier that in dynamic configuration, the configuration is stored externally. So it's usually going to be in a typical system, some sort of external system that's designed for this kind of thing, key value storage, secret storage, whatnot. A lot of systems actually exist for configuration management and will have additional features like audit logging, right? Or change logs every time a change is made, right? And these kind of give you the same equivalent safeguards that you normally expect to have on your source code, which things like Git or other version control will give you. And in my opinion, it's just as good. So let's do a pop quiz, because I think sometimes it's easy to confuse types of configuration. So let's say I have a file on the disk, right, on the file system that's being read at startup. What kind of configuration is that based on what we've just seen? Anyone? The second one, right, runtime configuration, exactly. Now, let's say that that file is a TLS certificate, right? Let's say that I have a website that I'm securing with Let's Encrypt, right? And I have a key pair sitting on the disk. And with Let's Encrypt, because it's automated, that means that every 45 days by default, I need to change the certificate file. And now I need to update the so that the software knows it. So I have a little script that's sending a SIG user 1 to reread that file. Now I'm dynamic configuration, right? Same mechanism, but I'm actually using a different pattern. Another example is containers. So there's a popular container pattern where you'll have your application container, and then you'll wrap another container around that where you'll put a file that has all the configuration values that you need, right? Which is going to be read by the process at startup. So again, it sounds like we're reading a file at startup again, and therefore runtime. But no, we're embedding it into the artifact, right? The container is going to be the artifact, and therefore we're actually using embedded configuration. So each pattern is really different with its own trade-offs. And if there's one key takeaway that I want you to take, aside from the three patterns listed here, right, it's understanding that there is no science to this. There's no right. I can't tell you, given this kind of application, this is the pattern you should be using. It's really, really dependent on the use cases. It depends on the type of application. It depends on the type of execution environment. It depends on the type of variable. And you need to learn and mix and match them. So getting back to our dinner date, what happened? So perhaps we were using embedded configuration, but we sent the wrong image to production. Perhaps we're using runtime configuration, right? I was doing a dry run of this with my friend yesterday, and he's like, dude, that just happened to me yesterday. My application wouldn't spin up, and it was because I added this new var3 config, whatever, and I forgot to put it in production, right? Even though I had it on dev and staging and testing and everywhere else. Perhaps using dynamic configuration, but the external server went down. And even though you should always be planning for failure, right? Because the dynamic configuration server going down is no worse than saying your database going down. You didn't. So I hope that these three patterns will kind of give you an oversight into, next time you're planning for something to not go wrong, or next time something goes unplanned and did go wrong, you'll have some idea of where to look. So unfortunately, we don't have time for QA, but as Andre graciously pointed out, it rarely happens with speakers, but I am very briefly available for hire. If you're interested in talking to me about an opening, come to me in the hallway afterwards. And aside from that, I want to thank you guys and hope that you enjoy the rest of the conference. Thank you very much.